Good afternoon, class. In this video, what I'd like to do is go over some of the different methods in which I solve kinematic problems. So this one is number 1 in the kinematic reflection questions for equation 1. So I thought I'd show it in two different ways. The first way includes all of the units, and this is the way that I would typically want to solve a problem to make sure that my answer is complete and it is definitely correct. This method right here is especially good for a two-step problem where I have to take this answer and then stick it into another equation to finish off the problem. However, if you're doing just like, for example, numbers 1 through 25 on the kinematic reflection questions, then there is this shortcut method that I have over here. And I'll go into detail on what I mean by all of those in a little bit. But first, what we do is we start with the basic setup of the problem. And so I put the numbers here in green and the variables and units in black. And the reason I did this was because I want you to understand that these green values, they can be interchangeable. They're the same. This is the same setup for any problem. It doesn't matter if it's number 1, number 2, number 20. It doesn't matter because the setup will always be the same. You will always start with, these are the things that I know, right? I know that x is for distance and it's got a unit of meters. I don't know how many it is because I wasn't told that in the problem. I know the initial position, I know the initial velocity, I know the time, and I know the acceleration. Those things are set in stone. That's why I wrote them in black. In green is to highlight that they're not, you can change them at any point. In blue, I wrote the next step, which is always to use the equation that I'm going to need. So I always put my given information on top, and then I put the equation that I'm going to use right below that. From there, I can then go on to the work. I use black in this case because the work is at least a little bit, it's a little bit easier to see. So let's just keep that in mind. Okay, so in this one, what I did was, so for number 1, I took all the information up here, and then I using this equation here, immediately I line up my equation. And again, by the way, this is not to do, I'm not doing this so that you can think of this as like, this is exactly how you're supposed to do this. I'm actually doing this to make it a little bit more visual so that you can see the steps that I am taking so that when you're doing these problems, you don't have to do it this way. This method is nice, but it's not necessary. What is necessary is that you take the proper steps to solve the problem. I thought I'd just try to make it look a little bit more visually appealing. So after I write down what equation I'm going to use, I'm going to go on to now filling in all of the information that I needed. So I don't know what x is, so I leave it as a variable x. Then I put in my x initial, which was 0 meters. My v initial, which was 0 meters per second. My time, which is 1 second, times 1/2, times the acceleration, which is 1 meter per second squared, times the time, 1 second, squared. Don't forget the square. That's actually a very important factor that a lot of students tend to forget. So what I do from there is I look at all of this and I say, oh, okay, I'm going to simplify my units so that I can make sure that the numbers that I put in there are actually okay. They're not bad numbers or I put in the wrong information. So I take a look at this and I've got seconds in the numerator here and I've got seconds in the denominator here. And as we did from our drill earlier, seconds divided by seconds is 1. I do the same thing over here. I've got seconds squared in the numerator and I've got seconds squared in the denominator. And like we did in our drill, seconds squared over seconds squared is equal to 1. So what am I left with in all three of these terms? 1, 2, and 3. The only unit that's left is the meter in all three of these terms, which is good because then I can actually add them together. I can combine the like terms and I get the answer that I need, which should make sense because x, which as we know from the notes in the notes for quarter 1, x is, as a variable, it represents distance, and the unit of distance is the meter. Now what I want to go over is the exact same problem. So before anybody, there's any confusion as to whether this method works on, maybe because doesn't work as well because it's a different problem. I'm using the exact same problem, but I'm going to use it with the shortcut method. The reason why I do it like this is because I found students in the past have told me that if you don't put in the units, it becomes easier, which is fine. I don't mind. I mean, as long as there is an understanding of how to do this problem, I'm okay with whatever method it takes. Eventually, I want us to get to this point where we can make sure that our units actually line up with our answer. But at this beginning part of the year, just for now, this is acceptable. What you can do is you look at this and go, okay, the unit that I want is meters because this is a variable x. So I want meters, so I'm going to assume that everything in here will represent meters at the end. That is an assumption that you're going to make, and for these type of problems, then I would say that that's acceptable. I know I'm repeating myself, but I want to make sure that I emphasize this method is not ideal. This method is, but this method right here is acceptable for now. So what I do is I take all of my numbers from here, my 0, 0, 1, and 1, and I plug them in according to the equation. What happens is then hopefully what you've noticed when I did this exact same problem, but I didn't put the units in, is that this started to look like your either pre-algebra or algebra problems, and that this is all should look a lot, quote unquote, easier, whatever that means to you. So then you start doing the math on this, right? 0 times 1 is 0. 1/2 times 1 squared is still 1/2. 0 plus 1/2 is still 1/2. The answer is exactly the same, and you bring the unit out at the end because you know what the answer should be. So this may be a longer video, but what I wanted to do was to highlight how to do a certain problem. And I use this as video as like a template, because at the end of this, you can use this method for any number, whatever number the problem gives. You can use it for any equation, because that's just the standard form. And the method that I showed you here, with either you're using the regular method or the shortcut method, whichever one you're using, this works for every problem that I'm going to be giving, that is any of the reflection questions that are being given in the class. This method will work. Next time, what I will do is I will go over a word problem, and I will show you how to translate that word problem into exactly this form, so that the next time you see a word problem that I give in the reflection questions, you can, once you've translated it to this form here, it will then be very easy, because you can follow these methods and solve the problem as well. So good luck in doing all of that. May the force be with you.